Yep. Okay, cool. Hi, good morning.
Morning.
How are you?
Morning.
Are you ready to make the web faster?
Yes.
Yeah? Okay, so you're in the right place. So welcome to Advanced Web Performance. we Today we're going to cover a lot of stuff. So I hope you're ready hope that your brain is empty right now so you can get a lot of information about how to make the web faster. My name is Maximiliano. I can go by Max. I know it's a long name. I'm third on social networks. I'm a mobile web developer. So I have been doing web development since 1995 and mobile apps as well. And in terms of web performance in particular, I've been working with web performance for 13 years. So I have started doing web performance specifically targeting mobile devices back in 2009, 2010, and then focused on more general web performance as well. I have authored a couple of books. Some of those books are on web performance. And also I have published many workshops on different topics around mobile development, app development, mobile app development, and web performance. I'm from Argentina. I'm currently living in Buenos Aires. Okay, so that's far away for most of you. And I don't know where you are, but typically Argentina is far from all the other countries. Anyway, I said Fear.dev is my website, @Fear my Twitter account. Regarding specifically talking about web performance, these are the latest two books that I author on the topic: High Performance Mobile Web and Hacking Web Performance. That, by the way, a gift for you. You will get a copy of the second one, that's actually the last one, Hacking Web Performance, later in PDF. Okay, so we will cover also the stuff that is actually on that book. So prerequisites, you can go and clone that repo, github.com/Ferdman, that's my last name, /adv from advanced web perf. There you will find just a simple website that we will use later to actually see in action part of the things that we will cover about web performance. You have a copy of the slides in case you want to follow along. And also you have a copy of that book that I promised. Okay, that's for future reference. We are not going to go over the book today. So questions? Yes, please, anytime. For those of you here in the room, for those of you live there online, go ahead. Ask all the questions that you have. If I have the answer, I'm happy to keep that for you. The idea here is for you to get a better understanding of web performance, not just on how, that's typically what we see online, but also on why. So why are we doing this? Okay, we will start talking about that, not just on how to do things, but why are we doing things. So I have basically two goals today. Okay, the first one is to teach you some new tricks that you didn't know about web performance. That's my first goal. And the second goal, and probably the most important one, is I want to make you feel bad about what you are doing and what you have been doing so far. Okay, so remember that goal. So so we are going to cover a couple of things. We're going to start with the problem, so why web performance is important. Metrics, so how metrics work, what are the metrics available today, how to measure performance. The tools available, some of the tools, there are many tools, but we will focus on the tools that we have available in the browser, open source tools, free tools, though there are also more tools that are more commercial. Charts and diagrams. Then we will get into understanding browsers, because we will get advanced in this course. That means that we need to understand how browsers work, to actually understand why are we going to apply some techniques. We're going to go over, even if it's an advanced training, we will go over the basic ideas anyway, the basic optimizations and why to start. And then we will push this further. I'm talking about performance. We will push this further with some kind of hacking tips. We're going to see how to hack performance with a lot of ideas. And then at the end, we will cover a couple of performance APIs. Probably not all of them, but I will give you a quick overview, and then you will have all the information to get deeper on other APIs as well. When we're talking about APIs, I'm talking mostly about front-end APIs, so JavaScript APIs. There are some exceptions there that are also working with your backend, but most of the time it's about the front-end. Okay, so let's start. The problem. So what's the problem? So if you're here, this is an advanced web performance workshop, you already know some things. For example, you already know that your users are actually sad. So you already know that you're losing money. Maybe not you, maybe the company you're working for or the customer that you're making websites for. But someone is losing money. Why? Because the web is slow. What you're doing is slow. I'm sorry to be hard on this, but you're making slow websites. That's the average. Okay, don't feel so bad yet about that. So the web is slow. And that has been proven. I'm not going to take too much time on that today, but it has been proven that that leads to less conversion. Whatever conversion means for your website. It can be less users registering to the site, less user buying, less user playing with your content, reading content, watching ads, whatever. Whatever conversion means for you, we have less of that if your website is slow. Okay? So, and also it's mostly front-end responsibility. That some people, when you are getting into web development, sometimes you feel that web performance is not about the front end. Sometimes you feel it's about, I don't know, the database, the cloud, the server. Of course, you might have server issues, because that's also possible, but that's not typically the case. When we have performance problem in our websites, it's typically because of bad front-end decisions. Okay, and that's, I mean, in this, let's talk about a discipline. So web performance is a discipline, web performance optimization, that has been in the web development era for probably 15 years. Before HTML5, let's say, to take one moment in history, when we were talking about performance, it was about, I don't know, Apache and how to make faster queries in MySQL or things like that. We were talking about the backend because we thought that performance had to do with server issues. And sometimes that was a problem, but it wasn't the biggest problem. Okay, and we will see why in a minute. So, and I know that you're already doing a couple of stuff. That's why you're here, right? So, for example, you're already optimizing the network transfer. If you don't know what that is, we will see in a minute. You're already working with TLS and HTTP2, at least. TLS is HTTPS, so you have like a secure origin. Okay. We will get deeper on each of these topics. Okay, so you have time to ask questions anyway. You're already using CSS as an appetizer. So, you know, appetizers should be first and typically small. It's not the main meal. Okay, so CSS should be first and small. And we'll understand why in a minute. JavaScript is dessert. So typically it should go after the main meal, and also it typically also small compared with the main meal, right? So you're already optimizing images, like using the right format with the right size and going through different compression tools. You're already defining a policy for HTTP cache. I mean, that's because, again, you're in an advanced course, right? You're doing this, right? You're already using service workers because that's kind of a base today for websites that want to run really, really fast. You're doing all of this, right? Because I'm watching you. So if we are all doing this stuff, that's kind of a standard, let's say, a checklist for web performance today. What's the problem? So why are we here? Why are we still talking about web performance? So this data is actually really updated. It's from yesterday. So today, the median on mobile devices for time to interactive, there is a metric that measures at which point in the loading process the website actually works. So I'm simplifying this, but that means that the website is ready for interaction. maybe you have seen this in action when you're trying to use a website and it doesn't scroll, you click and it doesn't click. That's because it's not interactive. Well, the median on mobile devices yesterday was 12.5 seconds to get into having a website completely interactive. And I know that some people here in the room or watching this video might be thinking, oh, that's fast. I don't know, because we don't know what we believe is actually fast. So to prove if this is fast or not, let's see in a timer, let's feel the pain of 12.5 seconds of silence. You feel it, right? So that's 12.5 seconds, and that's actually the median on how much time it takes to get a website interactive on a mobile device on real user. This is a real user metric. So this is measured on real devices, on real network, with real users, with real websites. It's not on the lab. So we have a problem, because that's a lot of time. Okay. Also, the average time to load the mobile landing page, this is actually from exactly before the COVID pandemic, but it's not better now. It's 22 seconds. Okay, so and the mobile landing page, most of the time, or sometimes, comes from an ad. So you have a company that is paying for an ad, and then for 22 seconds, no one is like seeing the whole content. And of course, I'm not yet explaining, okay, what's load, okay? Because that's it's a technical concept, loading a page, but we're not exactly sure what load means for the user. We will talk about metrics in a couple of minutes, but there are a lot of researches on this thing. And for example, there is a nice research that was done by Shopify, I think, where they did a research with real people on tables, like browsing websites, and they realized that for users, they feel like the website is loaded when the images are loaded. When all the images appears on the screen, users typically feel that, oh, okay, now we can use it. So as web developers, probably we know that that's not real. Actually, you can start using the website before the images are ready. But that's not important. What it matters is what the users are actually feeling. Okay? So the same Google research says that as page load time goes from 1 second to 10 seconds, the probability of a mobile visitor to bounce, so to get out of that website, increases by 133%. So, and again, think about that. When we're talking about landing pages, that's your moment of truth. That's the moment where you need to get that user, because the user is there, you already paid the cost to get the user there. The cost can be real money on an ad. The cost can be mental cost to actually the user goes into typing your URL or clicking on a link. So there was a cost. And then the user is getting there, it's going away because your website is slow. There was also, it was like 3 or 4 years ago, that there was a nice research on ads on TV for different like sport events, like really large sport events. Worldwide, it can be the FIFA World Cup or some other events on each country that are important. So they analyzed the URLs that were on ads. And they realized that they were wasting money because a lot of those URLs were actually really slow. So users were actually maybe getting into the URL and they were bouncing immediately. Okay, so that's a waste of money. And another problem, and we're still talking about problems, not solutions, another problem is how we typically underestimate the mobile space. And that's not new. We have been underestimating the mobile space for a while. I know that because I've been focusing on the mobile web since 2003, 2004, so before the iPhone. At first, I'm not sure if you remember this, but at first we were creating mobile sites like m.cnn.com. So we were making a separate website. Then at one point the iPhone appeared, and we say, oh, we don't need to do anything. So then we were just doing desktop websites, and then we'll let the user zoom in and out over the website. And then we realized, no, that's not good. That's not a good experience. So then we moved into responsive design. But we didn't think about performance on that. I'm not sure if you know this, but if you have 3 media queries, 3 different CSS files for, let's say, simplifying, desktop, tablets, and phones, you have 3 CSS files, every device will load the 3 CSS files, even if the media query is false. So every device, by default, is loading all the files. And we were thinking about that. So then users on slow 3G networks at the time were downloading CSS files for desktop and CSS files for tablets that was completely useless. So, and now we are underestimating mobile in a different way. We can say today safely that the mobile space is iOS and Android. We might have some small sparks of some other things on some special markets, but most of the time it's iOS and Android, which is okay. But what about browsers? Are we talking about Safari and Chrome? Is that enough? So if I try on my Mac, on Safari and Chrome on a small window with a simulator, is that good enough to say that it works properly on mobile devices? So what are the browsers that are actually having some market share? So let's go and see some information really in action. So there are a couple of websites that you can use to get information about the current scope of the browser market share. But one is gs.statcounter. That's global stat from a StatCounter, where actually you can see this is the browser market share worldwide on April 2023. That 63 is Chrome, then we have Safari, Edge, Firefox, Samsung Internet Browser. Have you ever tried your website on a Samsung Internet Browser to see how it looks like, how it works, what's the performance? And that's desktop plus mobile. But I can go and edit this chart and select only mobile. Even I can unclick tablets as well. So focusing only on the problem of mobile devices, okay? I can also select by region, so you can see how this is different on different regions of the world, even countries. View chart. And now we will see that we have users on Opera. We have users on UC Browser. Have you ever tried UC Browser? And by the way, UC Browser is taking a lot of users on worldwide because of some regions such as Asia. Okay, so now here is 3%. Also in US. So UC Browser is a Chinese browser that is also available on other countries. India. Have you tried? Probably not. And yeah, of course that Chrome and Safari are important, but you still have 4% of users, 3, 2, 1, on other browsers that we don't care. But you say, well, but that's like IE. Well, if you are paying for ads, you will have then 20% of those users accessing your website on those browsers. So it's not like 0.02% of your users. It's still 20%, 15% of your mobile users. So we should get the right information. Also, there are other sources of information. Cloudflare has just released also a Cloudflare radar. I don't remember the URL, but we can Google that. Cloudflare radar. That one, radar.cloudflare.com, where you can see current traffic trends. You can search for, I think that in adoption and usage, we have top browsers and user agents. So yeah, you can see it's Chrome, Safari, and Edge, but you can filter these also by region. And you can say, let's say, India. And you can see that now it's 90% Chrome, 3% Safari, 1% Firefox, and you can change that. Of course, this is the traffic from Cloudflare. Okay, so every information here is like a subset of the whole internet, but it will give us an idea. Okay? And there is another thing that is important, that sometimes these charts, these stats, are not actually showing us. These little guys here, Facebook, Instagram, can also be TikTok, but it depends on the OS. What is the problem with Facebook or Instagram? I'm not sure if you are users of those Meta apps. What happens when you click on a link on those apps?
Do they have their own dedicated browser?
Yeah, they have their own browser. And they don't appear on those stats as a separate browser. In fact, Meta has just created a name for it. It's a Facebook mobile browser, even on Instagram. That's the name they have. They're not like registered to the OS as a browser, actually. But they have their own in-app browser. And when you are browsing a website or a web app on those social networks, you are using a different engine that is not the same engine as the browser on that device. So have you ever tried your website there? The performance, the abilities, is everything working properly? So today, around 7% of global smartphone traffic comes from the Facebook or Instagram app. This is coming from a mobile report. There is an updated version as well of that report. They create a report every 3 months, I think. It's mobile report from Ciencia Mobile. So it's a lot, okay? That 7% is coming from social networks, and it's in the other stats that we saw before, they are actually under Safari or Chrome, because those systems, they don't recognize or they don't separate the real browser from in-app browsers. But the in-app browser has different capabilities, and they can be slower on the same device. Also, when we are browsing the web with mobile devices, we are using cellular networks. And I know that some of you are thinking, it depends on where you live, oh, we have 5G now, so we don't need to worry about performance anymore. Well, let's see. First, let's talk about real data, about real users. Today, so here we have in black, this is coming from the GSM association. This is where all the carriers on the world are actually grouped. We have in black the actual data from December last year, and in red the idea for the future. Okay, but we're not there yet, so we will focus on the black part. In terms of 4G, 60% of connections worldwide are 4G. Only 12% are currently 5G. Okay, so we still have around 30 on other networks. So, and this differs per region. We're not going to see all the regions here. I don't want to bore you with this, but let's focus here on 2022. You will see that, for example, in Asia Pacific, we still have 15% on 2G. I'm not sure if you have ever browsed the web with 2G. Have you? No? Lucky you. So, but it's not just 2G, we have 3G, but this is real users today, not 15 years ago, okay? Today, that they might be customers of your web app or website. I don't know, it depends on what are you doing, but if it's a global app, a global website, you might have customers there. So CIS, that is kind of the Soviet Union, okay, in terms of the region. It doesn't matter, but that's the region, okay, so it's a lot of ex-Soviet countries. So you also have a problem there because you can see that almost 5G doesn't exist. So we don't have 5G. It's 4G and 3G mainly, and also 2G. Latin America, I'm from Argentina, so this is Latin America. We have a lot of 4G. We don't have yet 5G. And yeah, we still have some users on 2G. Of course, that depends on the country. Yeah, North America, without Mexico, they didn't include Mexico here because, yeah, it's Canada and US basically. Almost you don't have 2G. In fact, in some areas it's completely disabled at this point. And yeah, you have a lot of 5G, okay, 40%, but it's just here. It's not the rest of the world. But even with that in mind, because maybe you're saying, well, you know what, my solution is for US customers, so I'm focusing on that maybe that's a possibility. But when we're talking about 2G, 3G, 4G, 5G, with the generations of network connections, most of the time we think on bandwidth, yeah, that the bandwidth is better. That is true. But when we are browsing the web, is the bandwidth really important? So let's say that, forget about the mobile world. Think about your home connection. Let's say you have 200 megabits per second. You have a connection 200, and then you go to 400. You pay more to your Verizon or whatever plan you have. You double the speed. Are you going to browse the web faster? I don't think so. Maybe you will see Netflix better. You will have more connections of Netflix in 4G, Netflix at home, but browsing the web is not going to be really, really faster, because the problem is not the bandwidth. The problem is the latency. And that's the time delay between when a data packet is sent and when it's received, expressed in milliseconds. In short words, it's the time that it takes for the data to get off your device and get back to your device. So from in this case, let's say your phone to the web server and back. That's the latency. Okay? If you're working with gaming, you probably know that better, because latency on gaming is really important. But you will see that on browsing the web, latency is also important, because latency is actually something that will be there on every packet. So every packet that you send, I'm browsing the web, I'm not sending data. Well, actually, when you're browsing the web, is the browser making HTTP requests, and that's sending data. So every HTTP request, to get the response, will have a latency. And that's currently the latencies in average on 2G to 5G. You have it there, the green area is actually it's a range, so min and max. On 2G is pretty bad. So that's why I said, lucky you, if you didn't have experience browsing the web with 2G. So in this case, sorry, let me get some water. So in this case, when you are connected in 2G, the latency can be between roughly a quarter of a second and like a second and a half. So that means you request one image, and the first byte comes after 1 second for every HTTP request that you have. Okay, 3G is better. You can see it's better, and of course 4G and 5G are increasing or decreasing the latency, increasing the experience. So yeah, it's better to have 4G and 5G. Yeah.
So why has 2G got such high latency? Because you could get like a photon around the planet like 8 times in 1400 milliseconds.
So to be honest, I don't have the technical answer, and that has to do with how the networks were set. So the frequencies that they're using, but I don't have the right answer of why. But I mean,
a lot of repeaters.
Yeah, it's about repeater, but not just about repeater. It's also about the frequency they were using for that particular standard or spec. And I think that also has to do with when 2G was created. We're talking about 20 years ago, and the needs were probably different. So the decisions they make was probably pretty good at that time, and then we started to need more and more and more and more, and then they changed the protocols, compression algorithms, and whatever. That's not my field, okay? But so I don't have the answer, but I think it has to do with at which moment that appeared and then how that changed. The same happened on modems on PCs. So we started with 3600 VPS, bits per second. Then we increase the quality of that connection over the same wire, over the same phone call. We improved that. So there were more protocols, better ideas over the same wire. So you can see that, yeah, we saw that there are still some uses on 2G. But even if we forget about those, and even if we are lucky enough to say, you know what, my users are not even on 3G, for whatever reason. When we get deeper in just 4G and 5G that we know it's not all the users, this is how it looks like. And the last one, it's a DSL home connection that you might have. You can see that even 5G is worse than a connection. That has to do with the medium. Okay, it's not the same to be wireless. Also on 5G, yesterday I've got some information from a friend that is working at a Canadian company, and he's working on that part, on connections, on 5G. So I asked him the real latency of 5G, because when you search for the latency of 5G, you typically get theory, like theoretical information. Yeah, it can be 1 second, 1 millisecond, sorry, not second, 1 millisecond. Yeah, but that's if the antenna is there, okay? It's not the real world. Well, in the real world, he said that today in North America, so not in every country, in North America, today is around 50. So the average is 50 milliseconds. So compared with DSL, that you can get 10, 12, 15, it's still high. Yeah, much better than 3G, I agree. But it's still a problem. And remember, this latency goes on every request that your website is doing to the server, because it's an upload, okay, and then you get the response. So Verizon, on their website, they say that latency hardly impacts smartphone user experience in advanced 5G and 4G networks. That's a statement from their website. The problem is that, first, that's not completely true. But anyway, not every country has advanced 4G and 5G. They might have 4G and 5G, but not advanced. And we still have 30% of users on 3G or worse. So it's not like we shouldn't care about performance on mobile devices. It's still a problem today. Does it make sense? Okay, do you have any question? No? Okay, so we still have a performance issue with the mobile web. And that's why we care about this, okay? But that networks is not the only thing. We also have CPU and GPU problems. I mean, not a problem, situations that happens in the real world. Maybe you're thinking, oh, but my iPhone is actually pretty fast, so I have a Samsung Galaxy S20 that has a very good GPU from Qualcomm, blah, 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 blah. It compares with my laptop, but that's not the real world. We are not the real world. That's from yesterday as well, with real users, and it's the median on JavaScript boot up time. So how much time it takes to actually run JavaScript briefly. But the important part here is the comparison between desktop and mobile. Okay, and you can see that mobile is much worse. Again, probably not for the phone that you have in your pocket, but that's not our users. We are not our users. Okay, so on mobile we have first that we are typically underestimating how it looks like. We don't try and test on every browser out there. Then we have a latency on cellular networks that sometimes we forget about that. And then we just test our mobile website, and even we test the performance of our mobile website in desktop Chrome with just a narrow window. And yeah, that's not the case because we are probably on Wi-Fi, but that has a DSL or another connection that has a different latency. And then we have CPU and GPU difference on real devices out there. So that's why we get into these 12.5 seconds that we feel it's painful, okay? And we need to solve that. That's why we're still talking about web performance. It's been a while since the community started talking about web performance, and we still need to push it further. So because when you compare that on desktop, that same metric, you will see it's half. So on desktop, the problem is still there. We will see if 6 seconds is okay or not. But on desktop, without changing the websites, it's better. Why? Because network is different. The network is different. The latency of the network is different, and also CPU and GPU is different. So it's better. So other places where you can see that difference, there is another metric that we will cover in a minute. It's called first contentful paint. And you can see that the median is different on desktop and mobile. So mobile is like slower by default. So all the metrics by default are worse on mobile devices. And by the way, mobile users are typically more than 50% of the users browsing the web today. It depends on the website, but it's typically over 50%. So we should care more about that because it's more than 50% and also are the ones that need more help from us to make a better experience. Speed index is also better on desktop, and probably you know what a speed index is, so we will get into that later. And we have a question.
Based on HTTP2 and having the possibility to have multiple requests without blocking each other, is it still important to think about limiting these due to latency problems?
So the latency on HTTP 2 or 3, or even if there is a 4 tomorrow, is still there. So the latency is not changing that. We will see that with HTTP 2 and that ability that maybe not everyone knows at this point what that means, will change how we think about some tips and tricks, but it's not changing the latency. So over HTTP 2, even if we are sharing the same TCP connection, every time we send a packet, a TCP packet from the browser to the server, we have the latency. So HTTP 2 is not improving or changing the latency issue. The latency is still there. It's going to improve other situations, such as how many requests you can start at the same time, and releasing some client and server resources, but it's not actually affecting the latency issue. Okay, so now we know the problem. So we have this problem, okay, and the next step is to talk about metrics, okay, because we can't improve, but we can measure. So we need to measure to improve something. It's not like I'm going to look at the website and say, oh, it's faster now because my brain thinks it's faster than yesterday. That's not how this works. And in terms of metric, we have two kinds of metrics today: browser-centric metrics and user-centric metrics. These are just two examples of those. We will get into the details. For example, browser-centric metric can be time to first byte or load. User-centric metric, content layout shift, largest contentful pane. We will see them. Okay? Typically, web performance originally were focusing on browser-centric metrics because it's something that the browser will tell us sometimes. So, what's a browser-centric metric? First, it's a metric that is important for the browser, so the user is not actually affected directly by the metric. Maybe that a worse metric there will affect other user-centric metrics, but not by itself. The first metric that we typically use is time to first byte, known as TTFB, time to first byte. Previously, we were saying this as backend time. Actually, the latency will actually appear here. It's the time that it takes for the browser to receive the first byte from the HTTP response from the server. So I'm requesting the index HTML, I'm requesting your website, and the server is doing something server side and returning me the bytes of that response, the bytes of that file. Well, at the moment where we get that file, that's time to first byte, and we measure that from the 0. The 0 is when the navigation starts. The navigation starts when you type a URL and press return, or when you click on a link pointing to that website. That's our 0. Okay, that's the beginning of the timeline. And then over the timeline, we will see different milestones. Time to first byte is at which point in the timeline the browser has received the first byte. And that means that, yeah, it knows that the server is there and is responding because I'm getting some information back. Another browser-centric metric is first paint. First paint will actually tell you at which moment in the timeline the browser has painted something. But that something can be a line or a background color, not actually content. Okay, so that's why it's not a user-centric metric. It's just can be white. can be black. So, but the browser took the decision to say, okay, we are going to start rendering something. Okay, and that's first thing. Page load is another one that is actually browser-centric, and that was actually the one that we were using before 2005. During the 90s and the early 2000s, we were using the page load time to measure performance. Do you know when page load is fired? Does anyone know? Page load? What page load means? What does it mean?
Is it when the last byte in the GET request arrives?
When the last byte arrives? No, it's actually further away from that. It's actually when the browser has nothing else to do about that page navigation, which means all the files were downloaded, all the resources were downloaded, and everything is painted on the screen. So everything is ready. Okay, that is including iframes that you might have if you have an iframe, even content that is actually below the fold. And we'll explain what that is in a minute, but after the scroll. Even content that is a mile away in the scroll. When everything is ready, page load is fired. Okay? And we realized after a couple of years that that's actually not so important for the user. It was important on the Internet Explorer era. Have you ever browsed the web with IE? Yeah, we have two and a lot of lucky use again. So on IE, at least the first versions like IE5, IE6, IE4, we used to have an animation, the logo. The same on Netscape, by the way, not just IE. So when you were loading a website, we had a logo that was spinning around. And the logo stops at one point. At which point? When the page loads. So there were a lot of users that were actually waiting for that logo to stop to start using the website. Okay? You remember that. You're laughing because you remember that. Well, that's actually page load. The problem is that page load needs a lot of time. And it's not so important because we know that the page is actually ready to use before that moment, before everything was downloaded, parsed, and rendered. We don't need to wait for that time. So it's a browser-centric metric that and we won't use anymore. It's not important. It's not an important metric. You will still get that metric from different tools, but it's not really important. Okay? In fact, browser-centric metrics are not so important. Yeah, some of the metrics will be important. Maybe time to first byte is something that we will check, but it's not really the ones that we will care the most about. Yeah.
So if you have an event listener for on-page load, it's going to be very pessimistic about when that JavaScript fires.
Yeah, that's correct. That's why using on-page load, on-load, or add event listener load, it's actually a bad idea today. And instead of doing that, you should be using DOM content loaded. DOM content loaded is fired when the HTML has finished parsing and the DOM is ready in memory. It doesn't matter what if the images are loaded, if the CSS are loaded, what happens with iframes. So you can start firing JavaScript there. So using the load event in JavaScript, it's a very bad practice today. But it was pretty common in the 90s or the early 2000s. I used that. Yeah, guilty. But it's not important anymore. We shouldn't be doing that anymore. Okay, so forget about page load. So during the rest of the day, probably we won't use page load as actually real metric. Sometimes we say page load, but we are not thinking about the real browser-centric metric known as page load. We will care about user-centric metrics. And the problem with these metrics is that they cannot be defined or expressed by code, actually, because it has to do with the user, how the user perceives performance. It's about user's perception. So we had to wait for browser vendors, first to the community, to define some units and some metrics and how to define the metric and how to calculate the metric. And then we need to wait for browsers to actually, or tools, to actually calculate the metric. Okay? So for example, we have First Interactive. That's one also known as Time to Interactive. Sometimes names might change. But First Interactive means that the main thread has been released, at least for a couple of milliseconds. So you know, well, I'm not sure if you know, that now you will know, that the browser has only one thread by default. It's a single thread. Everything that the browser is doing goes in one thread. Your JavaScript runs on the same thread. Okay? So if it's occupied by the browser doing something, you cannot execute JavaScript. If the thread is occupied by your JavaScript code, the browser cannot render because it's the same thread. It's like a highway with only one place for only one car at a time. Okay, so we have one lane, so only one by one. And first interactive means that the browser left some room for a while, so we can write our own code. Okay, what the browser is doing? Well, parsing, downloading files, parsing. Actually, downloading files can be asynchronous, so that can be in a different thread. But parsing and laying out and rendering, that is calculating the CSS and then actually making the rendering on the screen, happens in the same thread. So if it's taking too much time, you are not leaving space to execute JavaScript. Okay, so first interactive is at which moment there was some release. So actually it's interactive. Why is interactive? Because when you click, when you drag, when you scroll, the browser needs to receive the input from the user, from the scroll operation, the click operation. For that, it needs to be interactive. Speed index. I think that the speed index is pretty cool. It's underused. The first time you see the metric, it's not easy to get it. So let me explain what that is. Always, if you see even the number, you say speed index 3 seconds. I don't know what that means. So let me explain that with an example. We have here 2 websites. Okay, we have Gmail. Even you don't need to actually see at the bottom the real website, but here at the bottom you have screenshots of that website over time. So on the x-axis we have time, okay, and we have an ambulance or siren, so we need to wait. Now it's off.
Good.
Yeah. Okay, I will explain that again. So on the x-axis we have time. In this case, in milliseconds. So 100, 200 milliseconds, right? And then we have screenshots at the bottom. So we see screenshots of that website over time. What's the end? The end of the timeline is when the page is loaded. And then what we measure at any point in the x-axis is how much of the final rendering is actually rendered at that point. So, for example, here we see nothing because it's white. The line is over 0 on the y-axis. So the y-axis that we see here, actually at the right, it's actually percentage. How much of the final rendering was rendered at each point of the timeline. So when we start seeing a logo, we see here that we are going up on the percentage because now we see a logo. And then, of course, it's getting better over time. So a speed index, this is how you calculate the speed index. We need to make this operation. So we need to take screenshots of the website, and then we calculate the percentage of the final render at every point. Let me show you another example, and you will get the idea. This is Amazon. On Amazon, we see for 100 milliseconds, nothing, so we are at 0. And then, quickly, it goes over 75% of the final rendering, and then the rest until we get 100. Okay? Both are being loaded in the same time. So the page load time, it's the same. Let's say 1.3 seconds, roughly. Both. Okay? So both are 1.3 seconds. But which one is faster? Gmail or Amazon?
Amazon. The area under the Amazon curve is bigger.
The area under the Amazon curve is bigger. And is that better or worse? It's being bigger.
Feel faster for the user,
It
right?
feels faster. So Amazon feels faster because we render more content in less time in the timeline. So if you think about this, so what being faster means, we don't know what that means, right? But it feels faster. I like the idea of feels. So it feels faster. The perception of performance is better on Amazon.
So how does this? So what happens if, like, say, Amazon had like the last percent took 3 seconds? That curve would be very large. Is there any way like we normalize for?
So actually, we are not normalizing the value. In fact, I didn't explain what the speed index is yet. This is how you calculate it. So what the speed index is, it's the area above the curve, not below, the above. In this case, the grade area. The bigger the area, the worse. So in this case, when you are making the page load, I mean, you are expanding the x-axis, you will have more area. So what we need is to reduce the grade area. That, in short words, is like measuring how much blank the user sees over the page load process. And we need to reduce that blank, so that nothing that the user sees. Okay, makes sense, kind of? So the value that we receive as a speed index, it's a number. It's the area above the curve. But the number by itself doesn't say anything, so it's expressing which unit. Pixels per time, percentage per time, it's not important to understand the number, but how it's measured. And the number by itself, it's also useless. That's why we will talk a little bit about performance budget. So it's not just about the number. We need to define which number is good and which number is bad. Okay? So it's not just getting the value. It's knowing, oh, we are really bad or we are really good. So when you look at both websites, the loading process, you can feel that Amazon is better. Even the page load time is the same for both. And a speed index will measure that feeling. That's the idea, right? So a speed index is measuring that feeling, the feeling that Amazon is faster. Okay, makes sense? That's speed index. We will see how to measure these metrics in DevTools and in other tools in a couple of minutes. Time to interactive. Time to interactive, we saw first interactive first. Time to interactive is when, it's not just the first time it's interactive, it's that it's interactive enough for a couple of milliseconds. So you can scroll safely and you won't see chunks scroll or things like that, because it has enough time left for us to execute JavaScript. Largest contentful paint, also known as LCP. That's the one that we will focus the most for measuring a good loading performance, at least the initial loading process, LCP. Okay? LCP, largest contentful paint. We will explain that better in a couple of minutes with examples, but actually, remember, every metric in this case it's calculated over the timeline, and it's at which point in the loading process the largest contentful element of your screen was painted. What is the largest contentful paint? It depends on your website. It can be a text, a title, a paragraph of text. It can be an image. Actually, 75% of the websites are using an image as their largest contentful paint. It's like the largest part of your website that is actually content and not just a color. We will see some examples there. And also, you can create your custom metric, and this is actually pretty cool. You can define for your website, for your experience, what's a good metric. So, for example, Twitter used to have a time to first tweet. So when you get in twitter.com, at which point the user is saying one tweet, okay? And that's time to first tweet. So you can actually define your own metric. So then you can see how to improve that metric based on what the experience looks like for your users. Do we have a question?
Is time to interactive somewhere between DOM content loaded and load?
Typically, it's after DOM content loaded, and it can be after on load. So it can be between. That's probably the most common scenario, but it can also be after. I mean, if you are executing out of JavaScript, and I'm talking to you React developers, or Angular developers, or Vue.js developer that are not using a framework, a server-side framework, maybe that happens after on load. So it depends, actually. In fact, before doing a break that we will need to get in a minute, let me add a warning. I think I have that slide later, but let me add a warning at this point. With web performance, don't trust anyone. Don't even trust me. So you need to trust on the data. You need to measure and see everything in action for your website. And if you can, for your real users, with something known as real user metrics, RUM. So don't trust like the checklist, top 10 things you need to do to improve your website. Then you go and do those 10. No, it doesn't matter. So don't trust that, because every website is different. So you need to see a lot of techniques, test them, measure them, and see if that's better or worse. We don't have silver bullets here. So we actually need to measure, test, and then apply techniques, test again, and see if it's better or not for our website. Of course, we have some basic ideas that will apply for most or for all the apps, but for a lot of small things, it depends. So it depends on your website, on your content. Okay? Cool. Let's make a break. Yeah? 10 minutes?
That works, 10-minute break.